Okay, hi, I'm Paul Von Drack with LMI Technologies, and I'm coming to you live from beautiful St. Louis, Missouri at HTE Technologies, and about to present to you a Gocator demo. There's been a series of Gocator demos set up integrated with different robots. I think there's an Epson, there's some UR stuff, and several others that are on that you'll see if you've come through the different booths that are set up here at HTE. But specifically, I'm going to talk to you about a Gocator 2500 series model that we have set up here on an index, basically doing 3D inspection and reporting in real time of different items that are being presented to it. So remember, there's over 80 different models of Gocator, starting out basically at lower resolution and smaller fields of view and going all the way out to higher resolution. So basically 14 millimeters and 1 micron of resolution out to 2 meters and half a millimeter of resolution and everything in between. So virtually every model available, or over 80 models available for that. Switching over to the demonstration. So this is the Gocator user interface. So Gocators are all-in-one devices. They have web servers built into them. All you need is something running Chrome or a web browser and an Ethernet connection to get to the device, and it then serves up this user interface, which is used to configure it completely, set the I/O, set the tools, set up the acquisition steps, and then once you're completed with that, you can go to the onboard I/O and comms, remove the PC, and walk away if you want, or leave the PC attached and use it as an HMI. So looking at the way the user interface is laid out, so it's basically left to right, top to bottom. The manage step, this is basically where we manage the install of the sensor into the system. Things like IP addresses, firmware, jobs and job names and things of that nature, where you can have literally hundreds of different jobs on a Gocator and select them over the active comms links to run different parts and different functions and assessments. The security access is here, where you can set up 2 different levels of access into the system: an admin level that basically has everything and gives you access to the full system, and then a technician level that basically locks out the ability to make changes in the job files and just acts more as a monitoring entrance to the system. The maintenance area, basically we can go in and update the firmware in any active Gocator. Since they've been released back in 2009, we're on version 6.1 of firmware, with releases in between that about every 6 to 8 weeks or so. LMI does not charge for firmware updates or software support. So if you bought one of the original Gocators back in the day, and if it had enough memory on it, which it may not because of the depth of all the different tools that are available now and the size of the firmware, you could still access it for free and download it and run it on your Gocator from back in the day. So, and then last but not least is a support panel. And this is kind of a cool feature that comes along with all the Gocators, where you can collect images and record them on the Gocator, save it into a file called a support file, share that with LMI Tech Support, or the folks at HTE, and they can then load that into an offline emulator, look at the images, look at the tool functions, and make changes, save it, send it back to you. That can then be reloaded. So if you need to optimize something, or there's a question in function, support files are a global way or means for us to be able to assist people in making changes to their system and optimizing it. So on the next panel is our scan step. This is basically where we set the Gocator for the type of scan that we want to produce. What type of information are we looking for? What is it that we're scanning? And that involves things like triggers. So we can trigger the system either on a time base, where we tell it if it's over a conveyor that's a constant speed, we plug that speed in here and just hit go, and it will automatically create accurate 3D images of anything that passes at that speed. In this system, I have it actually set up to use an encoder that is my trigger. So as the system is moving, it's actually turning an encoder, firing the trigger to acquire the images and accurately depict the items on the scale. So encoder driven or time-based, either or. So this is also where I can set up and optimize the scan area for my sensor to focus in on a specific area or region, or to scan the entire full range, depending on what the application requires. Set the exposures, so there's multiple exposures that are available on every Gocator. So you can just set up a single exposure, which I'm running here, or you can go to multiple exposures for different surface types and features and reflectances for different parts. So some parts are more complex and have multiple reflection types in different areas, and sometimes you're looking at multiple different parts coming down the same conveyor, where multi-exposure or a dynamic range, which is the third selection that you can use, is available as well. So exposure set up to optimize the acquisition of the image of your parts. Spacing and scaling, basically we have the ability to subsample. So this particular unit that we're looking at is our high resolution 10 kilohertz is high speed, 2 megapixel imager. And we can reduce that down if we do not need all that high of resolution for an application, and actually improve or increase the performance overall of the system. So it's basically just releasing resources on board in order to optimize for the application. And then last but not least is our advanced step. This allows us to actually get in and control the imager and its acquisition, what is determined to be the focus point or a valid spot of data, and optimize the gains in the system in order to improve the performance and the image quality overall. Reflective, shiny surfaces, things of that nature may require some tweaking, translucent or semi-translucent materials versus opaque, things of that nature. So you can actually get in and tune the performance and the acquisition performance of the imager itself in every Gocator. Next, we have the alignment step. So basically, to align a Gocator in 3D space, it's really nothing more than installing it, setting it up over a surface. In this case, it's over the index, and hitting the align button, and it sends out a series of acquisitions to find that surface, find its position in 3D space and its orientation, and then set that as its 0 point and report back all subsequent values that it measures in real-world values off of that 0 point. So alignment is a single button. It takes just a few seconds to hit it, and it automatically sets the system up. Surface generation, this is where we can determine the type of image that we want to make. So if you're running over a conveyor, we want to run continuously and just draw images of everything that is presented. If you are end of arm of a robot, you want to tell it when to start and stop when you are in position. So it allows us to optimize the type of alignment for the type of acquisition that we need to produce. Rotary is also another selection within that. Each of them require or are for specific types of applications. Then we have the part detection panel, and this is unique that it allows us to actually go out and set permissives to determine when to make an image. So I get a lot of questions of people asking me, hey, do I need a photo eye in order to trigger this thing? And the answer is, well, you can if you want, but you don't really have to if you set up part detection properly. Where I've set it here over the index, I've told it, since I've aligned to that index, that's my 0 point. I've told it anything a millimeter or above that or higher, go ahead and make a picture of it. But you can set that by size of item, height of item, the area of the item as it comes through. That also allows you to ignore certain things too in certain situations where you may not want to make an image of something if it's too big. So, or if it's touching, or you can set the system to, it replaces that photo eye requirement and allows you to configure or optimize for the image acquisition of what you want to see. So we've said all that. Next, we want to determine what it is we want to do. We have over 153 different 3D tool functions on board the Gocator, or every Gocator. And for this particular application, I have two round caps that are virtually identical. One is missing the top portion of it, so it's just a millimeter or two shorter than the other one. Otherwise, they're identical. And then there's a rock. So It's pretty obvious the differences between the two, but the caps are virtually identical with the exception of the nub on the top of one of them. So I've set up the job file and added a few tools on board. One of them is Blob Sorting. And I want to sort the items on the platen or the index. I'll start that up by size. And you can see in the user interface that what my blob tool is doing is it's actually going out and it's marking by size the 3 items that it's finding out after it draws them. And it's also sorting them. So I'm able to select how I want to sort these items and report them. And I've selected large to small. But you can do it by position in the scan as well, whether it's from the X or the first from the left, the last from the left, or the smallest item, or the largest item. So we've selected the largest item, which obviously is the center rock here. And it's marking that as area number 1. You'll see it turns red when I highlight it. It is the largest item. I also get the full count that I do have 3 items, and I put that number in there because I knew that ahead of time. If I want 3 items, I can set a pass-fail basically on any of these values, whether it's the number or the count that it finds, the center X or Y value of the first item, its width or its length, and then its total area. And I can do that for any and all items that it actually finds and pass-fail on that through the outputs or through the comms links. The other thing that I can do is I can then send these images of each of these items into other tools to perform other functions. So we're getting the area here, but what if I actually want the volume? Because the area I can get out of a 2D system. As long as my height values aren't changing, I'm fine with that. But a 3D system, when you've got items that change, or if the height value changes from item to item or scan to scan, 3D really comes into play. And you can actually add this into a separate volume tool and get length, width, and height actual volume out. Where does that become, besides being able to identify by height, where does that become critical? Volumetrics, anything that wants to slice or dice by size and volume. So another tool that I've actually placed in the list here is a pattern matching tool. And again, I'm not going to go through all of these 153 tools on here. I just want to show a couple to kind of give you an idea for a baseline of what the systems are capable of. And the next tool I set up was I did a pattern match on one of the caps. And I told it, go out and now find all of the caps you can find in an image. And obviously there are 2 of them, but one is slightly different than the other. You can see that it's kind of missing part of the top of the cap on one of them. And that sets up a degree of match quality that we can subsequently then go pass-fail on. So the largest cap, which happens to be largest because it's slightly taller, is passing with a match grade of 90. And the smallest cap, which is just missing that small piece, is failing with a match grade of 82. Other than that, all of the other aspects of those caps are identical. So using 3D data to match items and degree of match for items. And I mentioned that we have the ability to place those images of each of those itemized items into other tools and perform other measurement functions on them, pass-fail on those. And here I placed them, the largest item, once again, is the rock, and I placed that into a surface volume tool. And now I can set pass-fail values for the volume, the area, or the thickness of that particular part. So all this is really cool, Paul. What can we do more with this? How does this fit into robotics and the event we have going on here at HTE? And I'm so glad you asked. So on the output page, we can set up the communications built into every Gocator is basically standard Ethernet, which we allow for a free download of a developer's kit and drivers off of the LMI3D.com website that can be used to develop your own interface and control a Gocator or Gocator system. We also have Modbus TCP, Ethernet IP, Profinet, as well as ASCII over Ethernet socket services that comes on standard on every Gocator. And that's, believe it or not, one of the most common interfaces that we use. So I know that we also offer a UR cap for the UR robots that is also free of charge. It's a download off of the LMI 3D website. If you load that into your UR robot, it relies on that socket services connection to actually control and set up and translate the Gocator data. So, and once again, it's a download off lmi3d.com/support, and then go to the UR robot kit and you can download that the UR cap. But anyway, setting this up or setting that up is done for you if you load the cap. If you don't and you want to do it on your own, you select ASCII, and then all you have to do is just start selecting the information that you want to port. So as far as which outputs data that you want the robot to act on, what is the XY center roll, pitch, yaw values of a certain item in 3D space. That's presented out of each tool that I've selected here. So once I find the largest item, I can easily report out those required, if you will, values on each of those items as I want or need them. So if I pass, fail based on size as the smallest cap and I want to go get it, I can easily grab its coordinates in 3D space and transmit that out to a robot control and pick it up, get rid of it. So we also have digital outputs. There's 2 digital outputs on every Gocator and a serial output, a separate serial output as well. So in a nutshell, that is the LMI 3D Gocator 2530 series 3D inspection system demo that I have for you today. Thank you for watching and have a great day.